Standing waves in a string. In this lab, we will learn about standing waves. What we see here is called a standing wave. Standing waves can be generated when two similar waves travel through the same medium in opposite directions. Using the phenomenon of standing wave, one can determine the speed of a wave of known frequency, or the frequency of a wave with known speed. In this lab, we are going to determine an unknown frequency, the frequency of vibration of this mechanical vibrator. But first, let us briefly review what a standing wave is. When a pulse traveling through a medium reaches the end of the medium and hits a rigid barrier, it gets reflected back. If instead of a single pulse, we have a continuous wave hitting a rigid barrier and getting reflected back, that creates two waves, the original wave and the reflected wave. They have the same amplitude, frequency, and wavelength, but are traveling in opposite directions. In general, these two opposing waves are out of sync and create a motion inside the medium that looks highly irregular and random. However, at certain particular frequencies and wavelengths, it so happens that the two waves always constructively interfere at some points and destructively interfere at some other points, giving a permanent steady pattern. The points where they interfere destructively, the medium particles do not vibrate at all. These are called nodes. And at points where they interfere constructively, the medium vibrates with twice the amplitude of each individual wave. These points are called antinodes. This string is attached to the vibrator at one end and passes over a pulley on the other end. We adjust the tension in the string by changing the weight hanging from the string until we have a nice clear standing wave, the first mode or fundamental mode of vibration.